Hello friends, welcome to my channel. Let's have a look at problem 2585, number of ways to earn points. In this video, we're going to share a treatment based on dynamic programming. So we are going to share two formats of solutions. One is in 1D DP and the other is in 2D DP. For sure, this kind of problem can also be solved using recursion with memoization or cache. So first, I'll read through the problem statement to digest the requirements, and then we do the analysis and the codings. So first, let's look at the problem statement. There is a test that has n types of questions. We are given an integer called target. So this is the total points we want to collect, and a zero index to the integer array called types, where types I equals count I and marks I. So this form indicates that there are count I questions of type I, and each one of them is worth marks I points. So we are required to return the number of ways we can earn exactly target points in the exam. Since the answer might be too large, so we return the result in the sense of modulo this big constant. So there's an important note which says that the same type questions are indistinguishable. So in other words, we need to avoid repetition when we do the coding. So here are three examples. So example 1 and example 3 are closely connected. So in these two examples, the types are the same and the targets are different. So in example 1, target is 6, so there are 7 ways as explained here. And in example 3, the target is 18 and there's 1 way. So actually you can add all the points, so it's exactly 18. In other words, we need to collect all the points from all questions of each type. So in example 2, the target is 5 and the types is given as here. So there are 4 ways, so you can digest with using the explanation given. So before we do the analysis, so we also point out that we need to look at the constraints. So in short, everything in the target and in the counts and marks are strictly positive. That's important to notice. So with that said, let's look at the treatment. So for the first treatment, I'm going to use a 1D dynamic programming. So here I'm going to interpret the generic element dp value as the following. So this represents or demonstrates the number of ways to get value points from types from all the list, right? So here value is in between 0 and target. So in other words, the dp table is of size or length target plus 1. So here, if we use this interpretation, actually the dp update rule is very verbose. So let's explain in the coding. So let's first write the version 1. So that's the 1D DP solution. So for convenience, I'm going to, or make it more clear logically, I'm going to write this like this constant, or you can write like this, int 1e9 plus 7. So 1e9 will give us a float point number. So let's change this type conversion. You can write it in this way, or you can write it in this way. And then what we're going to do, let's prepare the dp table. So let's write target plus 1. That's the size. Then we're going to set dp0 to be 1. So this initialization is easy to understand. The reason is that there's only one possible way to get 0 points. That is, we choose nothing. With that done, so let's do the dp update. So we're going to iterate over the types list. So let's see, mark. So let's see, they're using mark, right, in types. Then we're going to update the dp table. So we're going to update in the reverse order to avoid repetition. So for value in range, So we're going to use target. Then we are going to use increment by -1. That is, we decrement by 1. So we end at 0. So we write -1 here. And then we're going to see how many current type of problems we can use. So for J in range, so 1, right? So at most we have this number of current type questions. So let's write count plus 1 because this is not included. So we end at count. And then what we are going to do is to check if value minus J times mark is non-negative. If so, it means that we can try to pick J questions of current type. Then we are going to update dp value by dp value minus J times mark, right? So also let's do not forget to modulo this big constant. So this way we always make dp value less than this number, right? So let's also use a break to do early stopping. So if J is too large, so this number will be negative. So it means that we cannot choose that many questions of current type. So we just use a break. So this for loop actually finishes the update for the dp table. So now let's do the return. So we're going to return dp target. So you can also return dp -1, right? So this code actually forms one solution format. Before we do anything, let's first make a test. Solution here. So let's yeah, this is example 3. Now let's look at example 1. Let's use 6. So get a 7. Now let's test a generic case. Yeah, it passes all the generic cases. So this is one format of solutions. So let me copy this function signature and annotation and then comment here. Let's change this one to be version v1. So now let's write a 2D dp solution. So personally, I feel that the 2D version is more natural, or it's easier to understand, but actually these two are essentially the same. So for the 2D dynamic programming solution, I'm going to use this interpretation. So dp value and J, so means the number of ways to earn value points using questions starting from J and forwards, right? So if J equals 0, it means that we use all the list types, right? So the recurrent relation or the dp update rule is the following. So dp value in J equals summation of all the possibilities. We try to pick 0, 1, or 2, or valid number of questions of type J, right? So this is dp value minus x times m. So the x is the number of type J questions we are choosing, and m is this mark, so as here. So C and m is the types J. So what we are going to return is nothing but dp value 0 from this interpretation, right? So now with that explained, let's look at the coding. So I'm going to copy this part first. And then what we're going to do is let's just first get the length. Then let's use a 2D dp table. So 0 times 1 plus n. So this is if you regard dp as a matrix, this is 1 plus n is the number of columns. So for a dummy index in range, so I'm going to use target plus 1, right? So in other words, so this dp has a size 1 target plus 1 times m plus 1, right? So Let's first set for the value 0. So for j in range m plus 1. So let's see dp 0. So for 0 value, so j. So that's the only one way. We choose nothing, right? That's the 1. It's corresponding to the dp 0 equals 1 above. And next, let's iterate to do the dp update rule. So here for value in range, so 1 target plus 1. So here we are using the forward fashion, small to large. And then for j in range, so here we're going to use m minus 1, negative 1. So because of the interpretation here, so we need to update from large j to smaller j, right? So n plus 1, negative 1, and then we're ending at 0, so we write negative 1 here. So first let's get the current count and mark to be types j, right? And then what we're going to do is that, so we're going to, for x is number, it's the number of type j questions we try to use. For x in range, so c plus 1. Let's see. Then what we're going to do is to same as here. So we're going to check if value minus x times mark is non-negative, right? If so, what we're going to do, we're going to update dp value and j by, this is the increment, so value minus j times m. It's not j times m, so x times m. And then, so we're going to start from j plus 1, right? And then otherwise, so we use a break again. So it's similar as here in a parallel fashion. So we break. So here, after we do the update, let's not forget to do value and j. So modulo this constant, right? So mode. And then let's do the return. So we're going to return dp target 0, right? So before we make comments, let's also do a test. Yeah, it passes the first example. Now let's change this to be 18 for example 3. Yeah, it passes the example 3. Now let's look at generic case. Yeah, it passes all the generic cases. So with that said, I guess that's about it for this specific problem. So as we mentioned here, so yeah, maybe we can try to write DP solutions with recursion plus memorization or cache. So this is one extension. Another extension might be that like reveal the questions related to knapsack problem and also to coin change problem with different assumptions and constraints. So with that said, I guess that's about it for this video. Thank you.